much. Thank you all for coming and for this last talk. We're talking about catastrophes. I'm going to try to give this presentation. If anything goes wrong, there's my exception handler. Our fallback. I want to ask you, who makes perfect Python programs here? Can I? Oh, for you, you can leave the room. This talk is not for you. Because we try to do our best, make good programs, but exceptions do happen in production. And usually they happen at times that you are not debugging. They happen while the customer is using your program. And then we want to track those exceptions. And that's why we built Blunder. Who are we? Charlie and I work at a company called Dream Solution. We are in Delft, based in Delft, but we have developers all over the country due to our remote working, work from home policy. And we do Rust, we do Python, so we are a cool company. So what did we build? We built an exception tracking system, and we did that so we can track all the exceptions from all our applications, and we have many applications running, and we do that so we can catch those exceptions before the customer complains about something is not working. Now, while I'm talking about this, you think those applications already exist. Who knows Sentry? Who knows New Relic? And there are Glitch Lab. Okay, there are also open sources. So you can say, why don't you use those applications? We did. We used Sentry for a long time, and we really liked it, but they decided to go a direction that we didn't want to follow, and we wanted our data on-premise. So that's the reason why we did Blunder. Catching exceptions is fairly simple. When you have your application, it does something, and if something goes wrong, it throws exception. This exception can be logged onto a file, onto your syslog. And how it does is, Python does it with a logging handler. Now, we did this very simple thing. We just dump the log to the file system. The fastest way that we could think of. If somebody knows a faster way, more error-prone, or error-proof, you can tell us. But we dumped everything to the disk, and then we have a small agent called the Blunder client. It picks up the log file, compresses it, sends it over the line, HTTPS, to the Blunder hub, and the hub collects everything, does some digesting, and presents it in a nice way, hopefully. And the nice thing about the Blunder client that we built is it's language ignorant. It doesn't care how you dump it. You just dump it into a directory, it will pick it up and send it over. Just needs to have a special JSON format, but it's very simple. What I want to talk about is the application. How do you log nicely your exception? Because you have many languages in which Python is a very, very nice language to discover what went wrong. And in that I want to talk more about. But first I'm going to show you a little bit thing about the hub that we built. It's very simple. It's a Django-based application. We catch a lot of exceptions, like sending something called a CDR to our application that, a parse error occurred. Or like this one, a data error occurred, value too long for the type character varying. Maybe you say, hey, I know that exception. You users do it that in that database. Happens a lot. And we did something with the graphing, so you can see, at which time did some errors occurred? Did we already see the errors? If we don't, those are open. If it's resolved, we fixed it. And maybe sometimes exceptions happen, and they keep happening, like it's not our fault. The server on the other side is not receiving. They have an error 500. We acknowledge it. We say, okay, this thing can happen, but just mute it. Sometimes we want to see if it's still happening, but we acknowledged it. If we dive a little bit deeper, we can see, hey, where did it went wrong? It went wrong in the database on this error. On that remote address. We wiped out the IP address, but you can see who did it, on which platform, what was the error, and you can do some action on it, you can comment on it, you can give it to another developer, say, hey, you broke something, fix it, please. And you can see also the timeline, how many times did this issue occurred. Now, this is the way how we like to use our, see our exceptions and try to handle it. And you think, that's very nice. How did you get the source code into your exception detail? Good question. First, before I talk about how we did it, I would want to talk a little bit about logging. Most of you, I hope, knows a thing about logging when you program your application. And in Python, it's very easy to set up logging. You just import logging, and you choose a handler. Usually you don't, because most of the time this is already configured in your Django. But if you don't, you can just choose one of the built-in login handlers, like syslog, logging to your syslog, a stream handler, like to your standard error, or a timed rotating file handler, so your disk will not get full. And you can build your own handler, like our custom log handler. That is something that we built. Of course, not with these domains. And what you do in your program, you configure a logger with login.getLogger. Usually you do also a name between it, like the file name. And you send something like a .debug, .info, .warning, or .error, which explains which level you categorize your error. And you say something, hi, in debug, hey, the root locker is configured. Same thing in Django, you just configure it with an dict. And yeah, this speaks for itself. So when do we log things? When things go wrong in an except. And usually what happens is you raise an exception. You can also specifically say, I want to log this exception with this message, and then pass also the stack trace and the context into the logging message. And now I want to talk about specifically creating your own logging handler. How difficult is it? It's nothing more than this. You create a class inheriting from logging.handler, and you override the emit method. And you only have to set 4 arguments: the name, the level name, the message, and the args. That's it. And in that way, you can create your own logging handler and specify what to do with it. Of course, what we did with it is, with this information, we dump this information to disk, and then the rest gets handled. This is where things get interesting, because now we can dive into Python and see what Python does with an exception. We can collect everything that is on the stack trace in Python. Who knows a thing about the stack trace of Python? Who ever debugged and in the watcher, like PyCharm or something else in PDB, and goes into the traceback of an exception? Oh, quite a few hands. Nice. Then you know how much treasures there are in those variables. I want to show you some. The locals are the local variables that are on the stack trace on the level that you call the function. Something like where it went wrong. And you can go back into the history of the callers. And the nice thing about this, the whole context is available for you, including the source code lines. And that is the treasure. You can get the source codes from the method that is called in the stack trace that on the frame where you are at. And it's as simple as inspect.getSourceLines of the frame where you are. If you want to know where you are, you just say frame is inspect current frame. Just try it for once. You will be amazed how much information there is available in this context. And you can travel back with frame.fback. And what's almost so very nice about exceptions, because in Django, there's a general exception handler that catches all the exceptions. What happens if you just dump that exception? You get the Django exception handler environment, not the place where it happened. But then you can ask the exception, okay, go back in the timeline, in your stack frames, up until the place where it really happened. And that's where you will find the problem in your code. and we can collect everything in the context. How you traverse back is like with TB next. And then you have to reverse because often you want to see where it happened and not where the logging occurs.
There is, however, one very big issue when you want to collect everything happening. You collect everything. That is a lot. And when you want to log, or when you want to write all that information to a file, you very quickly run into some issues. One of those issues is lists. Because in Python, lists can contain lists. And those lists can be themselves. So you can put the same list in itself all over. If you're familiar with Drosta, you can perfectly recreate that. Now, if you were to write this to a file, if you were to just serialize this in a naive way with JSON, you'll quickly find out that does not work. So we need to fix this in some way. The best way we could think of is by limiting the amount of nesting you can do within a list. For example, when you have a list, you can say, I want no more than 3 levels. In our case, if a list is deeper than any 3 levels, we ignore everything after that. However, you don't want to silently ignore information. If you're debugging an issue and you're suddenly missing something, you might ask yourself if it's your code where it's missing. So we try to make it super very clear with this button. Max nesting reached, that this is an issue of the logging, not an issue of your code. Same goes for the maximum number of items in the list. If you're trying to convert a range of 1 million numbers into a list, you don't want to write all of that to your disk. So we do a similar way of snipping to make sure we can reasonably fit in a file without losing the information that it was, in fact, a large list. Another issue with logging everything is that you're logging sensitive data. If something goes wrong during a login attempt or during a registration, or if someone is entering credit card information, you don't want to write that to your disk. You don't want to send it over the line. You don't want to show it in a general hub, which all developers can access. So you need some way to recognize passwords. As with all big issues in computer science, we use a regex. Now, using a regex to recognize a password is a fun challenge. I would recommend you try and do it. I think it starts with seasons and ends with years, something like that. But to be a bit more general and to also support good password managers, we decided to write a regex for the name of the variable. Usually that's something with auth, as in authentication. There's something with cred, as in credentials, token, as in API token, etc. This is configurable. This is not hard-coded for this simple example. But this usually gets all of the sensitive data out of your dump file. How do we recognize those? Starting in Python 3.10, I believe, correct me if it's 3.11, you get your match case statement. If we find any item which is a dictionary in our stack dump, in our trace, we walk through it. We do this recursively, so to make sure that we catch all the dicts we can collect. If any such key matches the regex, we filter it out. We say, OK, this is sensitive. In this simple example, I've just used some asterisk. In the real code, it's very clear that this is censored. Lastly, we are Python. We have exceptions. Whether it's for the good, whether it's for the bad, everything can go wrong. It doesn't tell you in advance I can go wrong. You may be happy if the documentation says, hey, watch out, I can raise. But I have never seen a function that says, hey, I can raise if someone presses Control-C. But it still can happen. It still does happen. So you want to be resilient against exceptions when trying to dump your exception. For example, we have one class. I called it foo. And it raises an exception when you try to stringify it. The very clear people will see that I returned a value error instead of raising a value error. Guess 3 times what happens if you return an exception from your string function. It will still raise because it's not a string. Python does this for you. So the example code still works. This raises an exception. Now you need to handle that when trying to store your file, when trying to convert this to a string as the logger debug statement told you. So we need some try except. And we need it almost everywhere. So when you try to convert something to a string, when you try to call a function, when you try to access an attribute, you will need to wrap it with a try except just to be sure that you don't miss any information. Of course, since we are a debugging tool, you don't want to just throw away that exception when it happens. You want to know, okay, this went wrong when trying to stringify it. Why? So you will always try to put this exception in your log message. We failed to stringify this object because of yada yada. However, exceptions can be a custom class, they can have a custom string function, so they can go wrong. In essence, this means that you always have a fallback for a fallback, just in case you cannot say why something failed. This goes deeper. When we try to record something that went wrong, we always try to just process that record and write it to disk. However, that can go wrong because of an internal error. We are not perfect. That's the reason why we're making this tool. We too can make exceptions. So we try to handle those. And for your convenience, we try to record those as an internal error. They show up in the same place as everywhere else, just with the little name, this was a blunder, inside of Blunder. However, that too can go wrong. We are still not perfect. So we have another except statement. And then we just try to record irrecoverable error. Something went wrong. Please dive deeper into this. If you know what happened, please let us know so we can fix it. But we try to record it. You know the drill, you've seen the code. This can go wrong. So worst case, not quite worst case, we sent an email to root at localhost saying, hey, something is wrong with our entire stack. Please look into this. Here's an email. That can go wrong. We may not have a mail client available. So we accept it. We print irrecoverable error to standard error. Hope someone reads it. Hope very well. That too can go wrong. Streams can close at some times. And then we just exit. There's so much exceptions that I'm willing to handle. This is 5 levels deep. If someone can write an RFC to convert this into an except try, such as else if turned into elif, I'd be very willing to accept this. Now, we are at Pygrunn. We are not doing just Python. We are also welcoming friends. As Samuel already told before, this protocol is very simple. The things we are sending to the hub is a simple JSON with these two structures. If you're familiar with data classes, you know how to read them. If you're not familiar with data classes, please look into it. It's very, very nice function of Python to use. And what we do with these is just define what it looks like. We can turn this into JSON, and we can read this back from JSON. What it contains is the name of the logger. Usually that's my application. Usually even a file name after that. We have a level name. This was just informational. This was critical error, etc. The stacks, formatted in a way where we can optionally provide some locals, a file name, line number, source lines, whatever you have available. A message, the arguments with that message, and an optional context. Another part of friends is frameworks. If you're using Django, if you're using Werkzeug, if you're using some JavaScript, which you probably do if you're doing any Python web development, those two can go wrong. And they too have their own information you might want to attach to your error. For example, for web frameworks, that would be a user. If a user is logged in, then you want to attach, hey, it was this user making the mistake. Please ask them. Maybe they know more about why this went wrong. Maybe they clicked some special button you didn't know existed. So you want to attach that context as well. And you can. It's there in the protocol. Lastly, since I think we still have some time left, I've not received any guidance. So Django is a bit weird. Django tries to be your one-stop solution to everything with web frameworks. It tries not to let you reinvent the wheel, and so it handles all your exceptions, but not quite in the way which we would want it. So to teach Django that we are in charge of handling the exceptions, we need to write a middleware. Luckily, that's simple as it is. You get from Django your process exception. If anything happens somewhere in your Django view and this middleware is loaded, it will call this function for you. However, note that since we're walking back on the stack, that we're only walking back within Django, because Django catches this on the very high level and then calls this function. So we need to do some magic. We need to put the exception we got onto some semi-global. It is still local to the middleware, but it's global for your application. At least bound to your request. To put that exception information into the original call stack frame. How we do that is with a variable. Since we know how to extract variables from the stack, and since we know this name, please don't use this name in your projects because it might confuse some things. We know how to recognize it from the stack and extract this information back into the original payload. Thanks for listening. We hope you found some parts that you take back home, some parts you may use, some part of the inspect module, some part of the logging module, or even our module. It will be available on GitHub very soon. It will also be available on PyPI. Read through it, have a look, and if you have any questions, please let us know.
Questions for Samuel?
Yeah, I saw on one of the first slides you showed of the dashboard. I think that's something like DS Hub. So are you using your own product? Or you Blunder Hub? Are you dogfooding your own product for your own debugging?
So the original question was, do you use your own product for your own internal errors? Yes. If something goes wrong within this hub, we just log it to itself.
That is why we have those exception within exception within exceptions, because our blunder blundered. And you want to fix also those blunders. In the back.
Could you name some of the things that you didn't like about Sentry?
Could we name several things we didn't like about Sentry? First of all, the fact that they moved to Google Cloud while we want to keep all of our sensitive data on-premise. Second of all, because they very tightly pack you into their Docker file, which didn't really work on our architecture. And because it was such a big project, we didn't feel like we could contribute as much as we wanted to.
How well do you support async frameworks?
The question is, how well do we support async frameworks? Soon to find out. We don't use much async Python ourselves. We guess that it works because you're still inside an async frame, but we haven't tested it. So please let us know any issues.
But I can say a little bit about it. Use exactly the logging framework of Python. So if Python can log this thing, it can use this framework, this system. We do not do any magic about this. It's pure Python, just dumping something as JSON on the disk, and the rest of the chain is decoupled from the logging handler.
So we didn't get, but how are you going to license it?
The question is, how are we going to license it? And we are going to license it in the same way as all our other open source projects. So go back to the link. We have more projects available, and they are licensed under MIT or Apache 2 at your will, and this will most likely be licensed in the same way.
How about when out of memory occurs?
The question is, what about if an out of memory occurs?
Do you handle that with it? How much memory do you need to log the exception?
Good question. I hope not too much, but alternatively, we have other systems in place to track our memory usage. If that ever goes wrong, we are in deeper trouble than specific errors happening in Python.
We did log a server shutdown, so that we actually got that blunder.
We still have 5 minutes, so maybe one question. Did you have issues because you wrote your own exception handler and dive really into it and inspect into the Python code? Did it give some performance issues? Does it slow down your application while handling exceptions? Or?
Oh, I don't have to repeat the question. Yes, we did run into some small performance issues because we are walking back over the stack, the entire stack and all of its locals and all of its source lines. So yes, it has some performance hit. Luckily, I don't hope that you ever reach a situation where you have more than 1,000 exceptions per second. I think then you have bigger issues than our performance issues.
You still need your application monitoring. This is an exception tracking, not application monitoring.
Do you provide context decorators for more localized stack traces, so you don't go up the entire stack, but only the part you need?
The question is, do we have localized stack introspection so we only walk a certain part of the stack? So far, we don't. No.
But you can build it yourself. It's very easy.
Also because we haven't seen a need for it just yet, because we always want all the information to help debug us. And if you really want something else, you can override your wrapper function and say, hey, this object represents this, and then we use that.
We actually do that. We have a Django context and a Worksoy context because we use those both those frameworks. And if you compare those, you can easily see, oh, if I have this framework, I can do it the same way. Yeah.
Okay.
Besides the, you mentioned GCP and you mentioned that Sentry moving to Docker was a move that pushed you to develop this project. Besides that, do you have any special features or anything in mind that Sentry wouldn't provide for you where it's not for the DevOps issues?
The question is, do we have anything other than Sentry, or did we implement anything in this that Sentry didn't have, if I understood it correctly? Yes. One thing we tried to deviate from Sentry is Sentry always keeps an extra worker just to be able to upload the error when it occurs to their own central hub, which would mean that our applications would block for a few seconds when they crashed before the daemon restarted them. We didn't like that. We wanted our applications back as soon as possible, so we decided for Blunder to write to file as quickly as possible and then just kill the process, don't keep anything hanging. The daemon will pick it up.
Yeah. Well, thank you, Samuel and Charlie. Very nice presentation.